Hello students, welcome to SmartKidz tutorials. In this video, we'll be constructing another triangle where from exercise 11.1, the second question, it says construct a triangle of sides 4 centimeters, 5 centimeters and 6 centimeters, and then a triangle similar to it whose sides are 2 by 3 of the corresponding sides of it. What it's trying to say is we need to construct a triangle first. After we construct the triangle, so what does the triangle say? This is the triangle we need to construct. Okay, just a rough triangle. Say 4, 5 and 6. So let's say this is 6 centimeters, this is 4 centimeters, and this is 5 centimeters. Okay, now after we construct this, we need to construct a triangle that is similar to this triangle whose sides are 2 by 3 of the corresponding. 2 by 3 meaning the new triangle that is formed will be formed within this triangle, and it will be smaller than this triangle. How do you know whether the triangle is smaller than? Just by looking at this fraction, you can make out. If the denominator is greater than the numerator, then you will always get a triangle that comes within this main triangle. If the denominator is smaller than the numerator, then you'll have a bigger triangle coming on top of this triangle. We'll do such triangles in the following videos, but for now we'll draw or construct a triangle which comes within this triangle, which is 2/3 of this. So what is triangle? It says 2 by 3 of the corresponding side. So if we take 6, so 2 by 3 of corresponding side 6 becomes how much? 3 ones are 3, 3 twos are 6. So that means just 4 centimeters. Okay, so that means lesser than the actual side 6 centimeters. So let us do that. Let us construct this triangle first. So it says 6 centimeters. So we'll construct 6 centimeters first. From here to here we have this line 6 centimeters. Okay, we'll give this a name BC, and then what we'll do, so if we can say this is ABC out here, this one, and BC we have constructed as 6 centimeters. This is 6 centimeters. Then what we'll do is we'll construct AB 4 centimeters. Next, 4 centimeters. Draw an arc from B. Next, we'll draw 5 centimeters. So both the arc that is drawn from B and the arc drawn from C both should intersect each other, and we should get the point A. So take the scale, measure 5 centimeters, then I'll keep it at C. I'll draw another arc in such a way that it intersects the arc drawn from B this way, and wherever the two arcs intersect, the point I'll mark it as A from here, and I just need to connect A with B and A with C. There we go, and A to C. This way. So now we've got our triangle ABC. After drawing this triangle, now we need to draw an acute angle to B. It has to be less than 90 degrees. How much is the angle doesn't matter, it just has to be acute. This way. Okay. This is an acute angle. Now since it says the question says 2 by 3, so that means we need to cut 3 equal units on this line. Let's take 3 units. The actual measurement doesn't matter, you can take whatever measurement you like, provided you can cut this line into 3 parts, 3 equal parts with the same measurement. Wherever this arc intersects this line, I'll use that as the next origin. I'll draw my second arc this way. The same process I'll repeat once more. Here you go. So now we have we have cut this line into 3 equal parts. Once we have done that, wherever the third arc intersects there, that point will join with C this way. Okay. And we'll give this some name, B1, B2 and B3. So we've connected B3 to C. Now since it says 2 by 3, that means the second part we need to connect over here to get this line segment BC should be divided into 2 by 3. So we'll have to draw a line from B2 to BC, and that line has to be parallel to B3C. So we'll construct a parallel line. Keep the point over here and I draw an arc this way, and since we want it from B2, draw an arc using the same measurement this way, and now I'll measure this arc this way, and I'll keep that measurement, I'll give the pointer out here and cut this arc this way. Wherever the arcs intersect, I'll mark that point, and from B2 I'll draw a line such that it passes through that point of intersection meeting BC this way. And now you can see that this new line is actually parallel to B3C. Mark this as C dash. Okay, but this was not what we need. We need a triangle that is 2/3 of this bigger triangle ABC. So for that we need to construct another line that is parallel to AC this way. It should be C dash, and that line should be meeting AB, and in that way we will complete a new triangle, and that triangle will be 2/3 smaller than this original ABC triangle. So let's draw another line parallel. So for that, once again, take the measurement from here, I'll draw an arc this way, and from C dash, using the same measurement, I'll draw another arc this way. Now I'll measure this arc it, and I'll use that over here where I use where the arc intersects BC. I'll use that, keep that point as the origin, and cut another line with the measurement that I just got from measuring this arc. Now that the two arcs are intersecting, I'll mark that point here, and from C dash I'll draw a line passing through this intersection meeting AB this way. So this new line now is parallel to this AC, and I'll mark this point as A dash. So we have a new triangle. I'll make this slightly darken this triangle to help you to identify. Okay, this is our new triangle, and the triangle that we actually needed to show this is 2/3 of the new triangle. Okay, A dash B C dash is 2/3 of this actual triangle ABC. So in this triangle, this A dash B C dash will be similar to A triangle A dash B C dash will be similar to triangle A B C. Okay, because you see this angle is equal to this angle, and this angle is equal to this angle by construction. So by AA similarity we can prove that the smaller triangle is similar to the bigger triangle. Now coming to prove that these are the smaller triangle is actually 2/3 of bigger triangle, we'll take it by BPT. We can say by basic proportionality theorem, say B2 upon B3 is equal to BC dash upon BC. So B2 upon B3 is equal to BC dash upon BC. So how much is B do? See, it's just 2 units. So it's 2, and B to B3 is 3 units. So we get this equal to BC dash upon BC. So that means this we got 2 by 3, the whole thing. Similarly, by BPT, we can also say that BC dash upon BC is equal to BA dash here upon BA. Okay, but we also know that BC dash upon BC is 2 upon 3. So we can write this equal to BA dash upon BA. So we've got two sides which tells us that it is 2/3, and for this side, that is we can take since you can say triangle A dash B C dash is similar to triangle ABC, we can say that A dash C dash upon AC is equal to B A dash upon B A, but we know B A dash upon B A is what? 2 upon 3. So we get A dash C dash upon AC equal to 2 upon 3. So we can from you can say from 1, 2 and from 3 we can conclude that from 1, 2 and 3 we can say that triangle A dash B C dash upon triangle ABC is equal to 2 upon 3. And that justifies our construction. So if you have liked watching this video, the construction of this particular triangle, please hit the like button, share it with your friends and classmates. Please subscribe to the channel and do not forget to click on the bell icon. Thanks for watching. See you in the next video.